Alright, today I want to go ahead and discuss Lesson 11.5, Areas of Similar Polygons. Recall, if two polygons are similar, then their perimeters are proportional to the scale factor between them. And this is the stuff that we talked about back in Unit 7. The area of two similar polygons have a different relationship. Let's investigate what that will look like. Now, using the figure to the right, let's go ahead and figure out the perimeter of figure A. This is figure A. It's a rectangle. And since this is a rectangle, it means that it's a parallelogram. So opposite sides are congruent if this side here is 9 and this side is 9. And if this side is 5, then this side is 5. So I'm going to add up all the sides here. I should get 28. That's the perimeter of figure A. Now to find the perimeter of figure B, okay, this side is 9 times k, so this side is also 9 times k. If this side is 5 times k, then that side is also 5 times k. So I'm going to add up all the sides here. It's 5k plus 5k plus 9k plus 9k. Basically, you're combining the like terms. How many k's are there? Well, there are 28 k's. So I'm going to find the ratio of both of these perimeters. So let's take the ratio between the first or the smaller figure over the second, which is the bigger figure. So first to second. So the ratio is 28k divided by 28. Now remember, when you're writing a ratio, it has to be simplified. So how do I simplify 28k over 28? Well, I'm going to cancel the two 28s, and I'm left with k. Now what I want to go ahead and do is find the area of figure A. Well, the area of figure A, it's A equals base times height. The area is equal to 9 times 5, so area equals 45. So the area of figure A is 45 units squared. And to find the area of figure B, well, again, it's A equals base times height. A equals 9k times 5k. 9 times 5 is 45. And then we have k times k, which is k squared. So area of figure B is 45k squared. Now, let's take the ratio between the first over the second in terms of the areas. So it's going to be 45k squared over 45. Again, I'm taking the ratio between these two figures here. It's going to be the first over the second in terms of area. 45k squared divided by 45. Okay, remember, we're going to have to reduce, so I got to cancel the two 45s there. So I'm left with k squared. So the ratio of the areas will always be squared, right? Because remember, when we're talking about units, we always square our units when it comes to areas compared to the ratio of the perimeters or the scale ratio. So area is always two-dimensional, and when we're talking about perimeters, that's always one-dimensional. So let's write that down. Area is always two-dimensional, and when we're dealing with perimeter, that's one-dimensional. So perimeter, we were adding up all of these one-dimensional side lengths here. Well, the side lengths are always one-dimensional, and when we're adding side lengths, it's always one-dimensional, right? When we talked about that back in Unit 1, the points, lines, and planes, lines, line segments, rays, etc., those are one-dimensional objects, one-dimensional figures, right? When we're talking about squares, or when we're talking about rectangles or circles, etc., those are two-dimensional. So keep those in mind. Knowing this relationship comes in handy when you don't know all the dimensions of a figure and therefore can't find the area using the area formula for that figure. So let's take a look at example 1. Now suppose that triangle JKL is similar to triangle PQR. And the area of JKL, or triangle JKL, okay, so the area is 30 inches squared. Now, this means something. Again, it says knowing this relationship comes in handy when you don't know all the dimensions of a figure. So I'm going to look at this figure here. I don't know all the dimensions. I'm talking about the side lengths here. I have this 12 inch side length here, but I don't know what this side is, and I don't know what that side is, and that can be, said the same to the second figure, where I only have this 15-inch side length, but nothing here and nothing there. Suppose that these two figures are similar, then I can use something to figure out the area if the figures are similar, okay? Again, I'm going to say this right now. The area of JKL is 30 inches squared. But the area of triangle PQR is unknown. So the area of triangle PQR is our unknown. So I'm going to write X for that one, because X is always going to be our favorite variable when it comes to the unknown. Okay? Again, these two figures must be similar in order for us to do this type of procedure. Okay? So, what do I need to do? I got to figure out the scale ratio. The scale ratio of the two figures. Okay? So, the scale ratio, I'm going to go from the first figure to the second figure, 12 to 15, right? Well, let me go ahead and go back or backtrack. Let's take a look at this 12-inch here. 12-inch is the side of JK. So I'm going to go ahead and go back to the similarity statement here. Here's JK. It's the first two letters. So that means that JK is similar to PQ because it's the first two letters. So I can write my scale ratio. It's going to be 12 to 15. So 12 to 15. And when we're dealing with ratios, they got to be simplified. So make sure to simplify your scale ratio. That's going to simplify to what? 4 over 5. Okay? Circle that. You're going to need your scale ratio. Now, what I need to do is take a look at the area ratio. I have the area being 30 inches squared for triangle JKL, and then I have the area of the second triangle, which is our unknown. It's going to be first to second, okay? So let's write this over here. We have 30 over x. What am I supposed to put over here? Well, I'm going to put 4 over 5. Now, these two ratios are not proportional to each other, and there is a reason. Our scale ratio, and yes, your scale ratio will always be one-dimensional. Let's write that down. Scale ratio is always one-dimensional, so 1D. Now, this here, our scale ratio compared to this ratio, this one is one-dimensional. And this over here, since we're dealing with area, these are two, areas here. I'm going to write 2D below it. You have a one-dimensional proportional to a two-dimensional, which is something that we cannot go forward without doing something. Well, if this is two-dimensional and this is one-dimensional, I have to do something over here with this ratio. I gotta convert. I gotta convert this one-dimensional into a two-dimensional ratio. And how do I do that? I gotta square that. So I'm going to do that right now. I'm going to square this ratio. So what's going to happen? You have 4 squared, which is 16. And then you have 5 squared, which is 25. And then you don't do anything with this ratio because it's already, in 2D. So it's going to be 30 over x. And then now I can solve for x by using the butterfly method. We're going to be solving this proportion here. In fact, I just noticed that we can put this over here. Let's do that. Alrighty, so then we have 16 times x, which is 16x, equals 30 times 25. And then I'm pretty lazy. I don't want to multiply 30 times 25. I'm just going to go ahead and divide both sides by 16 here. So x is equal to, and this is where you're going to use your calculator. You're going to multiply the two numbers in the numerator, meaning 30 times 25, hit enter, and then divide by 16, and what do you get? You get x equals 46.875. Do we have anything here in terms of units? Yes, we have inches squared. And that's how you do number 1. Lots of steps, and it requires you to go back to unit 1, and it requires you to remember, okay, what's one-dimensional and what's two-dimensional, right? One-dimensional, again, you're talking about lines, segments, rays. Two-dimensional, you're dealing with squares, rectangles, circles, triangles, etc., etc. The stuff that we've been working in the past, which lead up to this moment here. All right, so the area of triangle PQR is this. All right, example 2. It says find the area of the second figure. Okay, so I have two figures here. I have the first figure and the second figure. We have 8 centimeters, we have 5 centimeters, and then this is the area of the first figure. It's 32 centimeters squared, and then the second figure is what I'm trying to find. So we're going to say A equals X because the area of that figure is our unknown. Now, what I'm going to do now is find the scale ratio between these two figures here. And the scale ratio will always be one-dimensional, so keep that in mind. So this here is a segment, one-dimensional, and this here is a segment, one-dimensional. I'm going to go from 8 to 5. So I'm going to write 8 to 5, and that's our scale ratio. And what am I comparing that to? Well, I'm comparing that to my two areas here. So I have, 8 over 5 being my scale ratio. Let's put one-dimensional up top so we don't forget to convert, which is equal to 32 over x, okay? So I need to be consistent when I'm writing my ratios. 8 is the first figure, 32 is the first figure. So those two need to be in the numerator, and that's also the case for these two things here. 5 centimeters is part of the second figure, and this unknown is part of the second figure, so they need to be in the denominator. Okay, so this is one-dimensional, and this is what? Two-dimensional, because we're dealing with area here. Now, these two ratios, they're not proportional to each other because they're different in terms of their dimensions. So I gotta convert. Which one do I convert? I convert this one. That means I'm going to square this. So that's going to become what? 64 over 25, which is equal to 32 over x. And this is where I'm going to cross multiply. I have 64, I have 64 times x, which is 64x. That's equal to 25 times 32. Divide both sides by 64 here. And now, put those numbers into my calculator. 25 times 32, and then I'm going to divide that by 64. What do I get? I get x equals 12.5. So the area is 12.5 centimeters squared. Alright, let's take a look at this example here. We're dealing with two triangles. So what do we see? We see 6, 8, 6 is part of the first figure, 8 is part of the second figure, and then the area is part of the first figure, and this area of this triangle is our unknown. So we'll label that x, so A equals x. I'm going to find the scale ratio, or the scale factor. Alright, so now what am I going to do? I am going to, okay, I see my one-dimensional object here, and I'm going to compare that to this one-dimensional object there. So I write 6 to 8, and then I'm going to reduce this, because 6 over 8 can be reduced. So that's going to be 3 over 4. And now I'm going to look at the two areas. Okay, so I have 3 over 4, which is equal to 13.5 over x. My scale factor is one-dimensional, and my areas are two-dimensional. So that means we're going to have to square the one-dimensional so it just becomes this two-dimensional ratio that I want. So 3 squared is 9, 4 squared is 16. That's going to equal to 13.5 over x. All right. Okay, so now I'm going to go ahead and cross multiply. I have 9x, so I'm going to multiply 9 and x together. And then I'm going to multiply the 16 times 13.5. I'm going to divide both sides by 9. So then 16 times 13.5, divide that by 9. X is going to be 24. So the area is 24 feet squared. And then I'm just going to change ratio, or I'm going to change this to factor. Kind of bothers me a little bit. There you go. Just got to be consistent with the notes. All right, scale factor, scale factor. All right, let's go take a look at example 3. Use the areas of similar figures to find the missing dimensions. The area of parallelogram ABCD is 150 meters squared. And the area of parallelogram FGHJ is what? 54 meters squared. Now, if these two parallelograms, which we talked about 2 seconds ago, are similar, then we find the scale ratio of parallelogram FGHJ to parallelogram ABCD and the value of x. So what I need to do is, let's find the ratio of the areas. So I'm going from this to this. So find the ratio of the areas from this to this. So it's 54 to 150. Okay, so it's 54 to 150. And then what am I going to do here? Well, I got to reduce it because it's a ratio. So we're going to simplify. This is where I'm going to simplify. So into my calculator, I'm going to write 54 divided by 150, hit enter, math, enter, enter. So I get 9 over 25. All right? So I have 9 over 25. So let's go ahead and find let's do the proportion before I talk about the scale ratio so it makes sense. Okay. Note that we're going backwards because, look, we're trying to find x. And note that this segment here, right, this segment is one-dimensional. And that's what we're looking for. And this segment is also one-dimensional as well. But we have the two areas this time, as you can see. So what I'm going to do is I'm going to write x over 10. And then, you know what, let's write x over 10 over here as well. So x over 10, and I'm going to compare that to 9 over 25. This x over 10 is one-dimensional, and then this 9 over 25, that was the ratio of this area, right? But it got reduced to 9 over 25. But still, this is two-dimensional. So what do you think I'm going to do with these two ratios here? I'm solving for x, right? It's one-dimensional. But this two-dimensional is in the way. So what am I supposed to do? Well, this time, because I'm looking for a one-dimensional object, and I have these two numbers, which are two-dimensional, right? I gotta take the square root. I'm going backwards this time. So take the square root. So you have what? The square root of 9 is 3. Let's use a different color here. The square root of 9 is 3, and the square root of 25 is 5. So your scale ratio is 3 over 5. So x over 10 equals 3 over 5. Now, this is where you're going to go ahead and apply your cross multiplication. So 5x equals 10 times 3. Divide both sides by 5. The two 5s will cancel. So x equals, okay, 10 times 30. So 30 divided by 5 is 6. So x is 6 meters. And that's your answer. Let's take a look at B. Okay, so we're going to do the same thing. So one-dimensional to one-dimensional, it's x over 6. And that's going to equal to, well, it's going to equal to something. But look at these two areas over here. We have 50 over 72. So 50 over 72. Let's see if we can simplify that. 50 over 72. Math, enter, enter. So that's 25 over 36. Okay? So I'm going to write 25 over 36 over here. Remember, x over 6 is one-dimensional. And then the 25 over 36 is what? Two-dimensional. Okay, you have a one-dimensional compared to a two-dimensional. You've got to take the square root of that two-dimensional ratio. So let's do that now. So x over 6 equals 5 over 6. Cross multiply. Should use my highlighter here. 6 times 5 is 30. And then 6 times x is 6x. So x equals 5 inches. And then C, same thing, but I'm going to give you the answer.
you are going to get, make sure you pause the video, attempt the problem, you should get x equals 16 millimeters. There you go. That's C. Alright, I'm done. Thank you so much.